Welcome to the House of Maths. In previous sessions we've been looking at right angle triangles and how to solve angles and sides in right angle triangles. But what happens if you've not got a right angle triangle? Okay, here we've got a triangle that's clearly not a right angle triangle. Well, we might be able to use something called the sine rule to help us solve problems involving sides and angles. So what is the sine rule? First of all, I'm going to show you how you arrive at the sine rule. So here we've got a triangle, clearly, as I say, not a right angle triangle. So I'm going to label the triangle. I'm going to call this angle A, and I'm going to call this angle B. So that's going to make this angle at the top C. Now, I could have called this one up here B, and this one over here C. So just remember that when we get to the end, I'll show you why that makes a difference. Okay, so opposite angle A is going to be side A, and opposite angle B is going to be side B. So we label up the triangle like that. Notice it's the angle's the capital letter, the side opposite the lowercase. So there's our non-right angle triangle. Now I'm going to drop a perpendicular from the top and call it H to represent, I suppose, the height of the triangle. And the reason I've done that is to split the triangle into two right angle triangles, like so. Now we can use our knowledge of right angle triangles to help us prove the sine rule. So I'm going to look at this triangle here first. Now I'm assuming that you know how to use SOHCAHTOA for right angle triangles. If you're not sure about that, check my previous videos. I'll put a link below for that. So we can say sine A equals opposite over hypotenuse, so H over B. Now I'm just going to multiply through by B to make this H equals. So we get H equals B sine A. Now I'm looking at the other triangle, this one here, and I'm going to say sine B equals opposite over hypotenuse, H over A. Now I'm going to multiply through by A, so that's going to give us H equals A sine B. Now notice the triangle, it shares H as a common feature. And I've arranged both these equations so that they are H equals. The reason I've done that is because I want to set them equal to each other. So I can say from this point that B sine A equals A sine B, because they both equal H, so they must equal each other. Now all I'm going to do is divide both sides, first of all by B and then by A, and that will leave us with, if I do that, that will leave us sine A over A equals sine B over B. And that is the sine rule. Now if you remember earlier I said I could have labelled this angle C. If I'd have labelled that C, I'd have ended up with that, okay, instead of this. Now that's the sine rule. Now you can equally write this the other way around, if you like, with these flipped the other way around. So you could say that A over sine A equals B over sine B. That's perfectly acceptable to write it that way round. So that's a sine rule, and that can be used to help us find angles and sides in a non-right angle triangle. Now let's have a look at how we find some of those angles and sides using the sine rule. Okay, so here's our triangle. This side here, we're going to say this angle is 50, this angle is 40, we want to find this, and that side is 10. So in order to use the sine rule, what you need are these pairs of opposites. So you need an angle and you need an opposite. Now in this case, we haven't got the opposite here, but we're trying to find it. Here we've got an angle and opposite. So if you have that situation, you can use the sine rule. It's going to work in this situation. Now in this case, we are looking for a side. Okay, so I would, in this case, put the sides at the top. So we are going to want to use the sine rule like this. So if I put my values in, if I call this A, and this side A, I'm going to get x over sine 50 equals 10 over sine 40. Now when it comes to rearranging this just to make x equal to something, all I need to do here is multiply through by sine 50. So if I multiply through by sine 50, in other words, I'm going to times this side by sine 50, and I'm going to times the other side by sine 50. Can you see on this side? They're going to cancel out. So I'm just left with x equals 10 sine 50 over sine 40. And now all I need to do is grab my calculator and work this out. This sort of question will be on a calculator paper, so you will be able to use your calculators. So I'm just going to do 10 times sine 50 divided by sine 40 equals, and that's 11.917. Okay, 11.917, and some more decimals. So if we wanted this just to one decimal place, we could say x equals 11.9. And that's using the sine rule there to work out a missing side. Let's have a look at what happens if you've got a missing angle. So again, we've got our triangle. Let's have a different angle. Let's have an angle up here. Let's say that's 80. This one here is, let's call it theta. That's what we're trying to find. So we've got this side here and this side over here, like so. So in this example, we've got these pairs of opposites. We've got this angle, and opposite it, we've got this length. We're trying to find this angle here, but opposite, we've got that side. So we're trying to find an angle. So we're going to use the sine rule. We're going to use it with the angle at the top. Like so. Now let's put our information in. So sine A over A, well, we'll call that A. So sine theta over the opposite side is 12. And that's going to equal sine 80 over 15. Now all I'm going to do here to get the sine theta on its own, I'm going to multiply both sides by 12. Okay, so I've got multiplying by 12 and dividing 12, they'll cancel out. So I'm left with sine theta equals 12 sine 80 over 15. Then I grab my calculator and I can do 12 sine 80 divided by 15, and that's going to give me 0.7878, and some more decimals. Well, we want the angle here, so we're going to have to isolate the theta. So theta is going to equal sine to the minus 1, and then what we've got there. Now what I would do is I'd keep this answer in the calculator. Don't clear your calculator, leave it there with all the decimal places because you don't want to round up at this point. So then you're just going to do shift or second function sine, and then you're going to put that, the answer, on your calculator. So you're going to put answer in there, which transfers the whole of this number into sine to the -1 and equals, and it gives 51.98, or we could round that up to 52 degrees. So this angle here is going to be 52 degrees using the sine rule. So the sine rule enables us in a non-right angle triangle, providing we've got these pairs of opposites, to find missing angles, or as in the previous example, missing sides. Okay, so that's the sine rule in action. Hope you enjoyed that. If you did, hit the like button and maybe think of subscribing. Thank you.